All right. Hey, everyone. Thank you so much for joining us today. We have a really exciting session. We'll get started in about 20 seconds. Want to give everyone time to join the call and kind of get comfortable. So yeah, thank you also to those of you who joined us last month. We had a really great discussion on kind of our own lessons learned here at Uptycs on Log4Shell. So if you're interested in that at all about kind of how we did our own, remediation, discovery, continuous monitoring of Log4Shell, definitely check that out. It's a free asset, download it. But yeah, we have a really exciting session today on eBPF, kind of a nice little welcoming to what is eBPF and also why we think it's kind of very important going forward for Linux security. So yeah, let's get started. So yeah, we have a really interesting session today. Solomon's on the call with me. Solomon, why don't you take a moment and introduce yourself?
Thanks, Jeremy. My name is Solomon Marungu. I'm a security sales engineer here at Uptycs. I'm fortunate to have been here for the last 18 very exciting months, working with a great team of engineers on a very visionary security platform. Prior to Uptycs, I worked at Oracle 2 different times supporting their database products. And before my second tour at Oracle, I was working at IBM as a sales engineer supporting their Guardian database activity monitoring product. And when I'm not working, I love to play Mbira music.
Nice. That's awesome. Thanks for that intro, Solomon. Yeah, so a little bit about myself. I'm a technical product marketer here at Uptycs. Prior to Uptycs, I worked at Deloitte focusing on day-to-day security operations and systems engineering for government clients. And yeah, in my spare time, I enjoy playing and watching soccer. So now let's take a look at the agenda we have for today. So we have a really exciting session and a lot to cover. Just a quick housekeeping item. We're expected to go around 30 minutes. We do have an open Q&A at the end, but we want to keep this interactive. If you have questions, feel free to use the Q&A feature. We'll try and answer it during the call, but if not, we'll answer it at the end as well. So we're going to break down our talk today into 3 sections. The first, an overview of just what is eBPF and why you should care about it. There's no knowledge assumed here, and hopefully it serves as a nice welcoming intro to the topic of eBPF. Next, we'll talk about challenges around Linux security and where eBPF can provide some solutions. And then finally, I'll hand it over to Solomon, who will walk us through kind of putting those pieces together on one of the many ways we leverage eBPF here at Uptycs and make it easy and lightweight to monitor Linux systems. So we left time at the end for that open Q&A, but of course, ask questions along the way and we'll keep an eye on the questions box. Awesome. So the first section here, what is eBPF? Let's get started. So you may be wondering, okay, let's drop the E for extended. Just what is Berkeley Packet Filter eBPF? So Berkeley Packet Filter is what it sounds like. It's a really interesting packet filter technology released in the 90s that helps filter packets through programs within the kernel. So eBPF, extended Berkeley Packet Filter, takes that further and extends it to you analyzing or filtering really anything, not just packets, in your operating system. So at its core, eBPF is a Linux kernel technology that can run sandbox programs in an operating system kernel. So I like this for your kernel. It's used to safely and efficiently extend the capabilities of the kernel without requiring any changes to the kernel source code or loading kernel modules. It's open source, extremely stable, and has a few verification steps for loading these eBPF programs and running hooks, but we'll cover that in an upcoming slide. So it's also not just about security. eBPF has like a really wide range of use cases that you can figure out. Security and observability is a big one, and obviously the one we're going to focus on today. But in a nutshell, though, I think it's just a really, really exciting technology because the kernel is such a great place to work in for efficiency or data availability. But I think a lot of us know it's also like a really nerving place to work in. If you don't have proper checks and balances, one wrong move in the kernel, you can crash the system or create these spiraling ramifications. And what eBPF does is it makes it extremely safe to work in the kernel. And it's creating some really interesting projects that are moving the needle forward in terms of innovation at that kernel level. So in the next slide, we'll cover user space, kernel space, as well as what is a hook in eBPF programs. So let's get started there. So in this slide, I'll give a high-level overview of eBPF, kind of focusing on the relationship of user space and kernel space, and then talking about the hooks or programs. So starting from the basic building blocks, apologies for any oversimplifying here for the sake of the webinar, we're going to divide the Linux operating system into the 2 areas, user space and kernel space, that you can see on the left. So looking at the diagram to the left here, it's from eBPF.io, which I encourage you all on this call to check out. They have a ton of great documentation and graphics on eBPF, and I'll be borrowing heavily from it throughout this presentation. So there's a partition between user space and kernel space. And we as users interact with our apps, services, in, out. We call this user space or user LAN. And the other side is where our operating system and hardware operates, and this is kernel space. So typically when we as admins want to work with the kernel, we use system calls or kernel modules from user space or kernel modules to work with the kernel and cross that partition between user and kernel space. The kernel is that foundation and privilege for unrestricted access across the CPU, memory, storage, NIC, et cetera. But that privilege comes with a trade-off that it's really restrictive as to how programs from user space are able to access or interact. The kernel is that desirable but dangerous place to work due to its access to highly valuable data and permissions. The trade-off there is that you can risk, crashing the system, et cetera. And there's another layer deep we can go in this conversation around how kernel space traditionally copies over data to user space and the performance costs with that, or the idea of context for data and mapping when translating across these spaces. But we'll keep it at that higher level for now. And where we want to introduce eBPF to the equation is it allows you to safely and efficiently interact with that kernel space using programs. So instead of relying on system calls or maybe plugging into audit D to monitor your events, eBPF acts like a sandbox within the Linux kernel space to run programs like system event filtering or network traffic level filtering. And this is leaps and bounds ahead of the traditional method of working exclusively in user space or relying on calls and kernel modules. And it really reduces that performance overhead, which we'll get into later, which is associated with monitoring and observability. So a quick note on hooks as well. So hooks are like event-based triggers for your eBPF programs. So when a hook is triggered by an event such as, like a system call or a network event, it then runs the eBPF program in the kernel. This can scale up to, a really high level of throughput for these hooks and programs. So now that we've talked a little bit about user space, kernel space, and kind of, the hook that occurs when you want to, run an eBPF program, let's step back and understand, as the program is loaded into the Linux kernel, it has to pass through two steps before being attached to the requested hook. Those two steps are the verification and the just-in-time compiler. So verification, there's an eBPF verifier that implements checks for any eBPF program that ensures safety. So I'll give a few examples of this. eBPF programs must fit in the size requirement of the system. They cannot use uninitialized variables. Any loops are guaranteed to have an exit condition that will become true, so you can never sit in a loop forever. There's also a hardening aspect, which includes making these programs read-only and has protection built in against kind of Spectre attacks. The abstracted runtime context means that an eBPF program cannot randomly modify data structures in the kernel, so it's very predictable and very safe. The next step in that kind of two-step process before attaching to a hook is that just-in-time compilation. So just-in-time compilation is when you compile code during the execution process of the program rather than prior to execution. And this helps with the efficiency and reduces the performance workload of running eBPF programs. Now, a final note on maps. So maps allow you to share collected information and share between different kernel programs or user and kernel space. So this is a really important piece of how programs share information back. And they're really interesting because they're actually somewhat flexible in terms of what data structures you can use. You can use an array, you can use a key value dictionary, ring buffer, and a whole lot more. But this is how you're going to do a lot of your communication back and forth. So now that I kind of hurried through the first section here on just what exactly is eBPF, hopefully you have a nice understanding of, recapping and looking at the key benefits eBPF brings forward. So eBPF essentially adds programmability to the kernel in a way that guarantees safety to the operating system. It's also really, really expressive, which allows you to use it for a broad set of use cases and tailored tracing. It offers a huge level of innovation for monitoring workloads and being able to reduce the performance costs needed to filter or capture events. Before I get into the next section though, Solomon, is there anything that really excites you specifically about eBPF?
Jeremy, definitely the programmability aspect is really a great feature. And I think as time goes on, we're going to see that the kernel is probably going to develop, additional helper functions to give developers, more flexibility in terms of, what they can extract from the kernel.
Yeah, no, that's such a good point. I think it's really interesting. eBPF just offers kind of so much potential at the kernel level that just wasn't there previously. Think of kind of the the staticness of a system call and kind of how defined and predefined that is. And using eBPF lets you interact with that really highly available, highly efficient space of the kernel, but kind of gives you that guarantee of safety as well. So the programmability lets you be expressive, lets you kind of try things out and really expand the broad use cases of it. Awesome. Yeah, no, I totally agree. So let's take a look now at kind of combining the fundamentals of eBPF and where it fits into the Linux security world. So one of the first things here is, Linux this decade. The Linux Foundation released a report that I read that I think it determined that companies added more Linux than any other OS in the past 5 years, which is really interesting. It's also really was competitive with Mac and OS, but even more recently, we're seeing just this purposeful shift to Linux as IT teams really like its modularity, its flexibility, and as the container space is rising, so too are people using Linux for that. The Linux Foundation report also stated that among early adopters who were operating in cloud environments, 70% were using Linux as their primary platform in cloud environments, whereas only 18% were using Windows. So it shows that as we're moving to a more cloud native environment, people are probably being more mindful and purposeful of using Linux. We're already seeing its popularity. 23 of the top 25 websites use Linux, 90% of the cloud infrastructure running on Linux. But this is great, but it's not without its concerns. We also have challenges around the rise of Linux as well. Every operating system has its exploits, has its gaps. Linux is no different. I'm not going to get into an operating system wars here. Don't worry, guys. But Linux adoption rates are really encouraging. But the good guys aren't the only ones taking notice. Attackers are publishing Linux malware, focusing on exploiting the rise of Linux attack services. And we're seeing an especially rapid rise in crypto miners, looking to capitalize on any additional CPU they can take over for their coin mining. Linux trends are optimistic, but there's still this gap in tooling and experience we're seeing with the modularity of Linux. So Linux is a powerful and secure OS, that's for sure, but it may require more knowledge than say like a Windows or a Mac OS to secure. And this may be due to the popularity or the amount of out-of-the-box tooling available for a Windows type software, or just maybe the widespread experience needing to catch up with the Linux adoption rates. So Linux is catching up and fast, but there's still this lack of security tooling and especially so innovation and security that helps move the needle forward for Linux environments. So that's where we're really excited about eBPF specifically, is how it comes in to the Linux security landscape. So looking at that Linux security landscape, it's easy to understand why we are so excited about eBPF. eBPF programs offer a level of interaction and programmability that wasn't possible before when you're trying to monitor these Linux workloads. So being able to perform extremely high volume event monitoring and reduce that performance cost is really monumental for teams that are scaling their assets like crazy. I think in a sentence for me, it's eBPF gives you more context and a better level of control over the security and event monitoring of your Linux systems. So some may ask, why is this better than plugging into an agent into auditd or something like that? And for me, the biggest difference between eBPF and auditd is that with auditd, you can get bogged down or cause conflicts if multiple agents are pulling telemetry from this audit source. eBPF just doesn't run into these types of conflicts. eBPF is less invasive, it's purely operating in a read-only mode, and it runs really close to the kernel, so it's more efficient. And it lets you gather that high volume telemetry data 24/7 without a real worry of being impacted those guarantees. So I don't want to sit on this section too long. I'm excited for Solomon to walk through the use case as well. If you have any questions about these first two sections, definitely drop me a note. I'll be monitoring the Q&A section, or feel free to save it for the end. But yeah, Solomon, I'll hand it over to you to walk us through a use case.
Excellent. Let me go ahead and share my screen. Jeremy, let me know if you can see my screen.
Awesome, I can see you great.
Okay, fantastic. So I'm going to go over how we use eBPF at Uptycs. And I'm going to start with the always query sensor. And then for those of you who may not be familiar with always query, is a sensor that allows you to query your endpoint operating system as if it were a relational database. This is the mechanism that we use to collect events that are happening in the kernel and bring them back to always query. So netlink is the traditional method that always query connects to the kernel to request data and get that data back from the kernel. And as you can see here, there is the user space component as well as the kernel component. So every time you do that, you're always going from user space to kernel, which requires a lot of context switching, and that adds a performance cost to to the data collection. And again, by using eBPF data collection, we're able to just inject that eBPF code in the kernel, and then it just runs and using those maps that Jeremy talked about to bring that data back. And of course, we're doing this extremely fast. There's no context switching. So we can collect all kinds of events from the kernel, whether they're HTTP events, process events, and socket events. And we're able to do this at scale because eBPF is extremely lightweight. It doesn't spend any CPU in the kernel. And with our platform, we've also added additional performance capabilities. One of the things that we do is we bypass the traditional OSCRI RocksDB, which sits on the endpoint, and we're sending that data directly to the Uptycs backend. And with putting this data in our historical flight recorder. However, before we do that, we're also detecting any anomalies associated with any event that comes in, and we're storing the data for a long time. And this gives us various advantages. Number one, we have the ability to go back in time and understand what has happened in the past. And number two, because we have all the data, we can baseline that data. We can understand the behavior of our endpoints, and then be able to use that baseline behavior as a tool to determine if there's anything anomalous that's happening with all the events that are that are coming in. So it's really a combination of two things. eBPF in the kernel is collecting this telemetry, bringing it to us in real time, and then of course using the historical baselining data in the data lake to to determine anything anomalous, and then of course there are multiple use cases that we can surface. So the example today is using the HTTP events table, which is and what we're doing here is we want to alert on a known or in any unknown JAR3 signature. So at Uptycs, we added the HTTP events table so that when an endpoint communicates with anything that's on the outside, we're going to use that encryption information as well as the JAR signature, all that information is going to be available in the HTTP events table. So what we're going to do here is we're going to look at all the distinct JAR3 signatures that we have in that historical flight recorder. The purpose here is try to use that as a baseline to understand what protocols our endpoints are using. So if we're to look over that data for a certain period of time and to realize that that number is not changing, then you know that it's really using a very constant set of JAR3 signatures. So the objective here is to take all those signatures and create an allowed list. And the Uptycs platform also allows you to build your own lookup table. So you can take that allowed list, create a lookup table. Then you can turn around and use the event wizard to say, build a rule that says, I want to know if there's any JAR3 signature that's not in my allowed list, and generate an alert. And we're able to do that very, very quickly. So in a sense, being able to have eBPF collecting this high volume data, bringing it into Uptycs, and we've got the mechanism to determine if there's anything anomalous, means that we're able to provide 24/7 observability. And again, it's the light nature of eBPF and its ability to get this data to us very quickly that makes it very, very special in this particular case. So here's an example of again, I mentioned the fact that we have this historical flight recorder, and we can go back in time and create it to find out how many events happened. In this particular case, I just wanted to know the events that happened in a single day. As you can see, we know 2.9 billion events, and that's quite a large number of events. And this is all happening without too much impact on the endpoint. The reason for that is, again, eBPF is very lightweight, so we can collect very high volume of events, bring them to without affecting the endpoint. Here's an example for process events. And again, as you can see, very, very high volume. And here's a summary of some of the eBPF tables and this scale and the size of the data that we have. As you can see, on a single day, we're up to about 6.5 billion records, and that's pretty tremendous. And again, to be able to bring all this without having an impact on the endpoint, it's one of the advantages that eBPF has. And of course, on the Uptycs side, we're also able to store all this data in our historical flight recorder, for as long as up to 97 days. So we have this rich set of data that we can use, again, like I said, for baselining, as well as use it to compare against inbound events.
Yep, Solomon, and I think, if you go back to that slide for a second, I think seeing how many events per day and events per minute we're processing, it really speaks to like the benefits of eBPF. I think there was a couple slides we were considering including in this presentation as well, kind of comparing benchmarks of eBPF versus other frameworks. And I encourage you to go and look those up as well, because it's really, really encouraging of eBPF is able to minimize the performance overhead, especially when you're scaling up to these hundreds of thousands of events per day. So this is just an example from Uptycs of us using it in action, and kind of an example of a case study from how many events we were observing per minute and per day, and how just well eBPF performed there. But there are kind of public research benchmarks that you can go and check out on your own and kind of see for yourself that the eBPF really does relieve your performance workload and overhead a decent amount. Sorry for interrupting. Go ahead, Solomon, but I just wanted to get that in there.
No, thanks, Jeremy. That's a very good point. So, so for the use case here, I'm just going to our data lake. As I mentioned, we maintain all this data. I verified that my JAT3 signatures are the same for the last 7 days. So I'm just going to go and collect those distinct signatures, and I'm going to download those signatures, and then go ahead and build a lookup table. And again, our platform is extremely flexible. As you can see, I'm able to go and run a query. I get a data set. I can download that data set, and then I can use it, for whatever purpose I want. In this particular case, I want take those non-JAT3 signatures, build them into my lookup table. And now that I've got those, I can again use the Uptycs platform query builder to say I want a rule that says, whenever I have a JAT3 signature, that's not in my lookup table, I want to be able to, to be alerted on it. Okay, this is really important, because when an event comes in, we want to make sure that, nothing is missed. And because, of course, in the back end, we've got eBPF, which is collecting all this telemetry, and it's doing so 24/7. So this means there's nothing that's going to happen on any of the endpoints that we won't be able to determine. And certainly, if anything were to happen, that event or that alert is going to be generated very, very quickly. And as I mentioned, the events are coming in, and we are going directly to the Uptycs backend. As the data is coming in, we're applying that that rule, those different rules that we have, to make sure that there are no anomalies, and we can surface those alerts very, very quickly. Again, this really closes the gap in terms of when you can see any anomalies that are happening in your environment. So in terms of some of the key benefits, at least from from our standpoint, we talked about performance, certainly not having context switches, because the eBPF code is resident in the kernel, makes it very, very efficient in terms of getting that data out to Uptycs. And then, of course, reliability. this is very disciplined code that runs under very strict condition. There's not a kernel loadable module that is the potential of crashing the kernel. So this gives users the confidence that nothing bad is going to happen to the kernel when you're running eBPF. And as Jeremy mentioned, the low resource utilization, right? When people buy virtual machines or any machine for that matter, they want to use them for running their applications and not any agents, and certainly having a low utilization is a big advantage. And then, as I mentioned, within the Uptycs platform, we go directly to to our backend where we apply the Lambda rules to determine anomalies and completely bypass the RocksDB, and that gives us the ability to be able to to scale as well. And then the historical flight recorder, as I mentioned, this is the source for any baselining information, as well as our ability to look back in time and see what has happened. So in a nutshell, being able to have the ability to baseline, build rules, and then collect and process all that data gives us the ability to have a 24/7 coverage of what's going on in the environment. We have seen lately other organizations using what are called agentless solutions, that sort of like scan the endpoints at one point and then come back and scan again. The question is what happens in between, okay? And eBPF gives us the ability to completely cover those gaps, to say any event that happens on any endpoint are going to be able to handle it, because the low impact on the endpoint, and of course on the Uptycs end, we're building a highly scalable infrastructure, and we're able to to close those gaps. And the value to our customers is time to insight, and everything's going to be set as very, very quickly.
Nice, awesome. Thanks for doing that. If anyone has any questions, feel free to ask. I've seen a couple kind of trickle in over the last few minutes and earlier on. I see one actually came in kind of talking about, what's the benefit of using eBPF over the audit-D framework, kind of talking about the stability of OS query and, where does eBPF come in to kind of reduce performance-based issues around OS query as an agent. And I think that's a great question. I would first start by saying that OS query itself is extremely stable. So there's not really any concerns there around stability of OS query. We found that when we do perform tests around CPU utilization, it's a very lightweight tool. And actually one interesting caveat of using OS query as an agent is that it captures so much high volume, rich telemetry that it's actually been used to replace a couple other agents. So we found some teams that, they've been forced to have a compliance agent, some kind of special monitoring agent. They can switch and kind of reduce from having 2 or 3 different types of agents to just having one OS query agent. Kind of getting a little more specifically into that question around eBPF over audit-D though, one concern around audit-D framework is that you can only have one consumer of audit events. And so using OS query there kind of creates a reliance on that audit framework, whereas eBPF kind of lets you be more flexible in using those audit events and filtering events and packets in the kernel. Yeah, so hopefully that answered your question. If not, feel free to reach out after. I can have someone kind of reach out and we can set up a call and dive a little deeper as well. But I do see a couple other questions as well. There's one question, maybe Solomon, if you want to take this one around, are there any drawbacks or caveats to using eBPF? Obviously, we covered the stuff that we find really exciting about eBPF, but Solomon, if you want to talk a little bit about maybe concerns or drawbacks.
I would say, maybe the drawback is eBPF is mainly on the Linux operating system, and it's available on a lot of versions of the Linux kernel. So if you're running an older version of the kernel, it may not be available there. And also it may not be as mature on other platforms. I know that there's talk about doing the same for Windows, so it may not be as mature as it is on Linux. I think those are the only sort of drawbacks that I can think of.
Nice. No, that definitely is in there. Yeah, I think they're starting to develop Windows. They have released a version for Windows, but I think it's a little more nascent, and I think the focus tends to be around Linux security and observability right now. So another question I'm seeing is kind of the agent versus agentless discussion, and you touched on it a little bit at the end. Maybe if you want to kind of expand on that.
Definitely. I think the agentless sort of paradigm came about because of kernel-based or loadable kernel-based modules that sometimes if they did not have enough compatibility with the kernel, they always cause the kernel crash. So they kind of get sort of like a bad name, the idea of having an agent that runs in the kernel. I remember in my previous life, we used something that was a loadable kernel agent, and oftentimes, customers would just sort of say, if anything happens, on the machine, they just immediately blame, that agent. And as you mentioned, I mean, the kernel is it's a very complicated place to work, and if you're going to put anything in the kernel, you want to make sure that it does not destabilize the kernel. So I think a lot of folks think that it's easier to just do an agentless solution, which works. But again, the issue that if it's not agentless, that means it's not there full time. That means that's where there's going to be gaps. And the question is, how do you cover those gaps? Are you likely to miss something? And we believe this solution that uses eBPF, very lightweight, get all the all the events that are happening, process all the events and service any anomalies. We believe it's a much more robust solution. And certainly for environments that are running agentless solutions, we obviously can come in and sort of cover all the different gaps as well.
Yeah, no, I think that's a great point. I know some teams that they think they can't afford to have a big heavy agent. And I think for me, eBPF just strikes this perfect middle ground between that agentless and agent debate of, we like to think of eBPF almost as like a sensor rather than an agent, because it is so much more like lightweight and acts like this 24/7 sensor of capturing telemetry and capturing your data similar to an agent, but doesn't have that negative connotation of feeling burdensome or have this performance overhead. So I think you answered it great. We'll do one more question I'm seeing that came in around containers. Yeah, so this one is kind of asking about how eBPF works on containers. So I think if you're not familiar, some people have concerns around audit D for containers based off of how containers handles namespace, or audit D handles namespaces and containers. And I'll just kind of quell this, eBPF works great when we use on Linux containers environments. I don't think these concerns really carry over into eBPF. And yeah, I think it works great. And we've been using it. We use eBPF at scale here at Uptycs. And yeah, if you have any other questions, though, definitely drop us a line. Our emails are right here. We really enjoyed this discussion. Hopefully you guys did as well, and learned a good bit about what is eBPF, why it's exciting, why teams are starting to use it, and why we use it here at Uptycs. If you want like a more personalized approach to eBPF, definitely give us a call. Drop us a line. I enjoy talking about eBPF or security and privacy in general. So just, yeah, feel free to email. Solomon, any closing thoughts from you?
No, Jeremy, as you mentioned, this is a very exciting technology, and I think as time goes on, it's not going to be just the way we use it for security observability, but it's going to span multiple use cases, and we're very excited and very lucky to be in a position where we can use this technology to to have a product that that's a 24/7 observability. So I think that's that's very exciting.
Perfect. Well, thank you guys so much. Thank you for joining us today. We'll be sharing this webinar online shortly, and you might see that in an email. But if not, just come check in. And once again, yeah, thank you guys so much for joining us. Have a nice rest of your week.